Hello, I'm Mr. Franz, and we're going to talk about pH and how to calculate it from the hydrogen ion concentration. We're also going to talk about how to calculate the hydrogen ion concentration from the pH, and we're also going to talk about such other things as the pOH and the hydroxide ion concentration. The first thing we're going to do is we're going to look at a sample problem that's on your example sheet for notes. The first example problem, number 1, says, what is the pH of a solution with a hydrogen ion concentration of 5.4 times 10 to the negative 3 moles per liter, or 5.4 times 10 to the negative 3 molar? The first thing we ought to do is look at some rules of thumb or some general rules to help us decide approximately what our pH should be. And that's pretty easy to do if we look at this power right here, 10 to the negative 3. Now you might remember when we did the foldable graphics organizer that we listed the pHs from 0 to 14 in the center. And we also listed the hydrogen ion concentrations just to the right of that. You found when you did your foldable that the pH, for instance pH 7, matched up pretty well with the hydrogen ion concentration 1 times 10 to the negative 7. So the negative exponent there, negative 7, indicated that the pH was 7. Just like the pH of 8 had a negative exponent 1 times 10 to the negative 8, and so on. So this number here and this number here are the same, except for that sign. Well, let's take a look here. 10 to the negative 3. So if we look down here at 1 times 10 to the negative 3, that's a pH of 3. So we would expect 5.4 times 10 to the negative 3 to be somewhere around 3. We can take the 5.4 times 10 to the negative 3, and we look down here, we see 10 to the negative 3. We have to decide, is 5.4 more or less than this 1? Well, it's more than 1. We can write it in decimal notation like this, and it's a little bit easier to see, 0.0054. Let's do all of these in decimal notation, and let's find the one that's closest. 1 times 10 to the negative 3 is 0.001. Where does this fall in relation to this list? Well, it falls right about here. So if we draw a line, we can see that 5.4 times 10 to the negative 3, or 0.0054, is a little more than 0.001, but not as much as 0.01. So our pH is going to fall somewhere between 2 and 3, so it'll be 2 point something. But what that is, we need to use a calculation to find out. Over here is the calculation that we're going to use. We can just follow the arrow from the hydrogen ion concentration up to the pH, and we'll use this equation right here. So first let's clear this stuff away and write the equation down. pH equals the negative log of the hydrogen ion concentration. Well, this is our hydrogen ion concentration in our given, so let's just substitute. pH is equal to the negative log of 5.4 times 10 to the negative 3. Now I just use the log on my calculator, and I don't put the negative sign in. I flip the sign after I'm done. When I do that, I plug in 5.4 times 10 to the negative 3 and hit the enter button. I get a number like 2.2678. Well, that's way too many significant figures to show for a pH. Remember that these pHs are exponential. Every pH number, 1 to 2, 2 to 3, is 10 times, or 1/10, depending on direction, of the number just before it. So 2.3, just one figure after the decimal place, is as far as we want to go.